Suppose in your hand there is one triangle, so it has 3 sides. So based on that 3 sides, you have to compute some output. So we will generate test cases based on that, and again depending on the cuckoo search, we will generate those test cases. So when we look at the problem, the classification of triangle, so we have this possible outcome. It can be the invalid input. You will provide the range outside the module, discard the word solution repository. No further refinements are needed. So then we'll go for the code coverage analysis. So till this part, the start WSR deals with your cuckoo search for the test case generation. Now this is the control program for our random solution. The cuckoo lays it as in a other host, bird host nest. So we'll take the idea that we have some random solution with us and the existing solution, we'll combine them, we'll evaluate the result. So the only similarity between the genetic algorithm and the cuckoo search is the fitness evaluation. We can say the fitness part, we are evaluating the fitness based on the fitness function, and second similarity is the number of generations. Whatever the word solution with us, it will move to the next generation. But in genetic algorithm, we have to do the crossover of the individual solution. Applying to the DNA computing, you can say. After that, the crossover, we perform the mutation. Again, mutation to small problem vectors, optional testing of the software testing area in the functional testing, the black box domain. So in the black box domain, few existing techniques are, for example, boundary value analysis. Everybody has studied it. So for boundary value analysis, it's something like that. On the boundaries, you are checking whether the thing works in the appropriate manner or not. So that is the drawback of it. Initially we are checking the 0 value, then we directly move to the 50th value. So there is a gap between that. So while applying the bias-spike evaluation, it works on the neighborhood principle. Neighborhood principle means the nearby solutions, they are checking it whether it is optimal or not. So we get the consistent result throughout the span. So that's why I picked this, the bias-spike algorithm for software testing problem. So software testing, a lot of work is going on using bias-spike. For the cuckoo search, I have done it for the first time. Then a lot of work is there. You will find many papers, but in March 2010, it was mine.
I'm sorry, I enjoyed myself. Anyway, any other question that you have?
Kavita, I think is something very interesting.
The Darwin concept in software engineering. I am also using the Darwin in test. So I'm really curious about because you have many steps during the optimization. So how you validate each step before production? So is there some validation or something?
Some validation, for example, on my part, on MATLAB I've generated it. So when we look at the graph, for example, I've implemented the PSO. So when you look at the to validate your results, and definitely I've tried all the problems, but I always found that system works more than our brains. So it simulates the result in the effective manner, whatever we are doing it manually.
Yeah, I think it's a very unique idea to use such inspiration of some biology to
we are providing to that problem. So redundancy allocation problem. For example, now you are going for the solution. So now solution in the market, again you are going for the optimized.
Our more speaker, Dr. Namita Mittal, she is the assistant professor at MNIT. I would request Dr. Poonam Sharma ma'am for the floral welcome of Namita Mittal ma'am. Poonam Sharma ma'am.
This is a demonstration of Wirecast.
Thank you so much, ma'am. Even I would thank Professor Ida also for chairing. Request Professor Ida.
This is a demonstration of Wirecast. 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 Demonstration of Wirecast. This is a demonstration of Wirecast. This is a demonstration of Wirecast.
If we do this thing, this data should come. If we do other things, data should come. These are the what if capabilities. So, first of all, when we talk about the data, a term comes that is information. Everybody must know, or you must be knowing the difference between the data and the information. Data is a raw data fact. But what is information? It is a processed data. For example, if I have data, say 99, this figure I have taken, 99, 102, 102.5 and so on, it doesn't carry a meaning. But if we process it, it conveys something. If I say, this is the hourly temperature of a person, it means it conveys something. It may be a body temperature of a patient. Hourly temperature of a person. It conveys something now. Before that, it doesn't convey anything. When we process a data, it becomes the information. And when we do something on information, it becomes knowledge. What is that? If we say, using this example, if I say that this is a hourly body temperature of a patient, then knowledge, it means if we say the temperature is higher than 98, if it is in degree centigrade or degree Fahrenheit, then if this temperature goes beyond the 98.4, that is the body temperature, then a person or a patient must have a fever. Then comes the wisdom. So there is a hierarchy of data, then information, then knowledge, then wisdom. So it is a hierarchy like this. We have a lot of data, then we process it, it becomes information, then we again process it, it becomes wisdom, then we have the knowledge. Wisdom, sorry. The wisdom is that if we have a persistent temperature, beyond this, the person should go to the doctor. This is how the data works. So, a process of transforming data into information and making it available to users in a timely manner, then there is a big difference. So, we don't want a data, we want information in such a way that we can use it appropriately or on a real-time basis. So nowadays you must have heard there are very large databases. These are the terminology you must have heard it. So zotabyte 10 raised to power 24 bytes and these are the applications where we are having so much of data like Walmart, geographic information system, national medical records, weather images, satellite images. To that business, if you have a different one, then data will be different for that business. So in another picture you can see data warehouse, and here these are the different source systems like CRM, industry, payroll, sales and others. Similarly we have different sources, different businesses, different reports. If we can keep these report systems, so like web data, e-commerce, purchase of department, grocery stores, bank, credit card transactions, they are making us lot of data. This is the commercial viewpoint. The computers have become cheaper and more powerful nowadays. We can afford it. Like powerful computers we can afford in a very low cost. But the thing is the data. How mining? Look up a phone number in a phone directory. That is not a data mining. That is a, we can say, it's an example of database. Query a web search engine from information about Flipkart. You type it in a Google and get the information. That is not a data mining. So what kind of data mining? what's likely to happen in a Boston unit sales next month. इतना हो चुका है, अब क्या होगा? Right? Then we need to write some queries using the data mining. Every flower of A will have these type of properties. If we can classify all the plants of B, C and D with these features, that is attributes, properties or features of a class. So we start with class in a supervised learning, class or label. Find a model for class attribute as a function of the values of other attributes. It means what is the class? Class or label is again attribute. But we can find that attribute if it is an unknown sample or a test class, appropriate class for the test classes. This is the classification. Example of classification is we can apply the classification in such type of applications like fraud cases in credit card transaction. A person is going to get a credit card. What is the possibility that he will pay? It is not a fraud. It means what are the possibilities that it will pay on the basis of his behavior? A person in 3 clusters. जो भी हमारा डेटा है, what are these dots? These dots are the persons. हर person को हमें इस ग्राफ में accommodate करना है on the basis of income and debt, right? So the nearness inter or inter-cluster similarity or intra-cluster similarity. There are 2 types of similarity. जो एक क्लस्टर में जितना पास है उनको हम एक क्लस्टर में रखेंगे एंड जो जितना दूर है वो दूसरे क्लस्टर में हम रखेंगे. That's how we have to processing also. We can use clustering. Medical diagnosis can be used to determine what should be done to boost sale. ऐसा क्या करेंगे मिल्क की सेल बढ़ जाए, right? या मिल्क इन एंटीसीडेंट can be used to see which product would be affected if store discontinues selling milk. अगर मिल्क खत्म हो गया या नहीं बेच रहे हैं तो इसका कैसे रिवर्स इफेक्ट दूसरे आइटम पे आएगा. Similarly, we have other rules. We can increase the sale of using these tools. So in real life or in a society that occurs before any data mining, data warehousing is the process of compiling and organizing data into one common database, that is a summary. Summary is must. We cannot use all the data. According to summary, it's like an index. According to summary, we can say yes, that data is useful to us, our application. We should go in this data warehouse or not. Data mining is the process of extracting meaningful data from the database or data set. The difference between data set or database is always structured. Everything is in a proper format. We have set of attributes, and under the set of attributes we keep the data. While in case of data set, those are generally semi-structured or unstructured. It means there is no tagging, no attributes. Here and there, data is lying. Say text document. These are the unstructured data. One text cannot be together with the other text. While in case of database, if we have one record and that will be similar to the second record, all the features will be same in the second record as well as to the third record. So data mining process relies on future prediction. Then this is an example of data. Weather data एक यहाँ से लिया है. इसमें day, outlook, temperature, humidity, windy, play. This is we can say this we can store in DBMS. That is structured one. हर attribute के नीचे exactly उसी domain का data है, उसी range का data है. Now DBMS में किस तरह की queries हम पूछेंगे? What was the temperature in the sunny days? ये attributes हैं अगर तो इनमें ये result आ जाएगा उसका. Which days the humidity was less? जो भी हम SQL में queries लिखते हैं इनके आंसर मिल जाएंगे. बट अगर हम OLAP की बात करते हैं तो हमें बस एक समरी बन के आएगी. That is say data queue. If you can see it is 9 by 5. It means total 14 days थे हमारे पास इस डेटा में. इस डेटा में हमारे पास 14 days थे. उसको हमने 2 weeks में डिवाइड कर दिया. तो 14 days how many times it is play or not play? Say play is 9 times and not play is 5 times. Sunny, rainy and overcast. ये सारे किसके थे? आउटलुक के एट्रीब्यूट्स थे. प्ले में था यस और नो. तो ये सारी 3 चीजें थी हमारे पास जिनको कि हमें यूज करना था. दैट इज द वीक 1 में ये डेटा था. एंड इंस्टेड ऑफ हैविंग अ बिग टेबल नाउ वी कैन हैव अ समरी इन डेटा वेयरहाउसिंग. नेक्स्ट इज डेटा माइनिंग. हाउ डू वी राइट द डेटा माइनिंग एल्गोरिथम? वन ऑफ टाइप इज डिसीजन ट्री. Here's the example of data mining. It says outlook is sunny. Outlook की value अगर sunny है, humidity is high है, it is say you can go for play or not. It is no. Humidity is normal. In a real life scenario, it works like an information. It provides the facility and the hardware, software and infrastructure without having that. बिना हुए भी हम use कर सकते हैं उसको. So cloud enables delivery of information and functionality to users and systems. What is the cloud computing? Cloud computing is the delivery of computing services over the internet which allows individuals and businesses to use software, hardware that are managed by third party at a remote location. जाना चाहिए कि नहीं जाना चाहिए? What is this? Sentiment analysis. Sentiments जो है positive, negative, neutral that can be used. That is again application of data mining. Then mobile, anytime, anywhere we can use it. It is a critical for businesses to excel in today's competitive environment. Today organizations are facing pressure to be innovative. Everyone has to be innovative, something new, something better, cost sensitive too. Then it gaps the bridge. It gaps the bridge between the people and process by providing access to critical time, to real time, to real sense. अभी कुछ हुआ तुरंत आपको न्यूज़ मिल गई. That is the thing we want, right? And that we want a personalized to. हम चाहते हैं कि हमारा जो मोबाइल है that should be personalized to our needs. हमारी जो needs है उसको fulfill करे. So as business organizations, they are sensitive to the perception of the customer or they take care of the personal need of the customer. The next is the analytics, that is the big data. 2.5 billion gigabytes of data is generated every day. You must have seen these values. 90% of the data available today has been created in past 3 to 4 years. पहले इतना data नहीं था. And everything just because of cost sensitive, storage space and other things. Operating computers and networks don't have to invest in infrastructure. They don't have to do it. Just they have to have an MOU with the cloud. I'm about to conclude. The new buzzword big data. You must have heard the term big data. Big data is a collection of small data. Not a data is huge, but the properties are similar like telecommunication, financial data analysis, biological data analysis, other scientific applications where we can apply the data mining. This is all about the data mining and its application. If you have any queries?
How is it strong?
How is it?
Strong competitive pressure in data mining.
Of course, there is a lot of pressure for the businessmen who is using the projects.
In Malabar University. So please welcome them with a big round of applause.
This is a demonstration of Wirecast.
Then again, it's being a research for the society, by the society, and for the individuals who are not being used, which are being let's say we call them as the deprived students in the future or in the society. So starting up with this, I have came across with lots of data being used out in the Facebooks, where our information being lagged, where our information being scrutinized by the various other agencies, and we are just providing our information on the clouds. So it's being a mass to be dealt with, and at the same time what we are finding out is that anything that goes into the error basket, the transaction be considered as cancelled. The transaction is being considered as cancelled. So think of an algorithm that has been developed. The hacker has studied the algorithm in a sense that every time he is taking out 10,000 rupees, he is just taking out an 8,000 rupees and let 2,000 go back. every time he's taking out in 10,010, and he said out that the theoretical analysis reveals that there is a generalization of the mass estimation. We use the data mining concept, which we call as density estimation. Now we are replacing the density estimation with a concept named as mass estimation. And he come across the following research here, which were the handy one for us before actually coming into the picture. So studying the first research here, what you're finding out is that the classification, clustering, anomaly detection, information retrieval and negation, both being the part of the density. My ultimate statement comes out was to develop a classifier which is based upon the mass estimation. It can support a large data set and have less time and space complexity that actually we have achieved. So we destroyed this objective into two parts. We have said out we have a new base modeling mechanism for classification. We have developed this and determining the superiority of the mass estimation over density estimation or distance in terms of efficiency for classification. The efficiency and efficiency differs in terms of efficiency is something that my algorithm is able to hold what exactly has been proposed in the past. And efficiency means that my algorithm is able to support what actually I am producing in the nearby future for my particular algorithm. So efficiency and efficiency, both the things have been clarified in this particular data set. So these are the data sets that were huge in amount, let's say in lakhs, crores, which is huge in amount, and we have captured this particular data set. We have designed our software in Java. We implemented this particular software in Java in BICON, and then from BICON we able to realize that there's some algorithm is good. So these were the software and the solution programming language tools. The only point of concern for us is it requires an 80 GB hard disk minimum to actually capture the data. First thing. Secondly, it requires a 8 GB RAM architecture to support my algorithm. So to run fast. So being hardware being low in cost, for me time was superior. So we designed this particular thing. And we use out Windows XP. It can be done out on Linux also, and BICON 3.7 because of algorithm mass estimation algorithm works on 3.6.1. So these are some of the data sets that we have collected. Think over here, the number of instances actually goes up to 10x. The only problem that actually we are facing out in these data sets were and later on all the algorithms have been designed by us. Later all the algorithms bar charts have been processed by us. The only point or what exactly the research goes into this is whether we test out the data that जितने भी likes मेरे पास आए हैं वो सबके सब positive likes हैं या negative likes हैं. So randomness उसमें नहीं है. If we have out of 10,000, 9,999 goes in favor of the document, so it is a biased result. So if the data set is being random in nature, then we are finding out that things goes better. If the data set are random in nature, then we are finding out it goes higher. But if the data set is not being random in nature, like magic 4, setup, and the satellite of material-based data and the cover type small data, we are finding out that the results are showing out the better results. Rather, these values. This is again k equal to 5, then we have tested out for k equal to 10. Maybe my algorithm goes wrong for the various values of the k. And this is the average runtime in terms of the kn and the ARS kn. So we just think of, we are starting off from minus 0.5. The only reason was to show that our algorithm is showing something. Only reason of putting this particular bar to be starting from 0.5 is that I want my algorithm to show that we have produced something. And if in case the data has a random behavior, much larger random behavior, you are finding out that IBK algorithm is coming up with 3 seconds and 3 milliseconds, and our algorithm is coming up with these particular values. With the concept of what we call as mass estimation, it's a new market, then always go to these particular papers, calming thing. So that's why we have not tested on this, but otherwise we have been in touch with, we have our own hospital coming up in Jaipur, Manipalis. So we have taken the data set from Manipalis for the last 30 days, and we are working on authority. But with the private banks,
I asked someone for this, they said it's illegal.
unless and until, that's why I said, unless and until it doesn't cause
review and the sentence review, then main classifier display the result in a positive or a negative way. Further, Google Analytics, Twitter States and Scientific Insights. The rest will continue by ma'am.
Here are the technology, here are some application areas in which we are using money. Nowadays, if you want to purchase a product, for example, in phone, first you are selling. Any questions, students?
Yeah.
This is a demonstration of Wirecast.
I'm about how to design special types of algorithms. The title of my talk is Designing Algorithm is Additional Memory Space. Which are to read rewrite, let's say, non-adjusted workspace algorithm. The first one is the such algorithm performing on arbitrary size workspace. The second is
Wirecast.
algorithm using less workspace rather than input size, let's say n. So for example, using on workspace, first search for this first search is for given graph G and with this
Demonstration
space
of
and
Wirecast.
but the number of vertices is n and the number of edges is m. So this first search is a fundamental algorithm for searching on a graph. It's expressed as much as possible along each branch before backtracking. So you know a simple implementation using in or n of n bits. So our curiosity question is, can we make then its algorithm consists of four. It doesn't have next white neighbor vertex, so it's the search is n. Then move to stage 2, and we find backtrack vertex, which means that we got this starting point, then we tracing gray vertex. In this figure, A and B and F and so on. Again, we back to a starting point as a tracing a blue vertex. Then we
Is the associate professor in RTU Kota. I would request Dr. Poonam Sharma ma'am for the floral welcome of Dr. C.B. Gupta.
Let's give them a big round of applause.